Welcome to month 3 of the Senior Copilot Studio admin track. This is the engineering session, the technical depth that separates platform administrators who can govern agents from those who can also design and validate them. After month 1 built your foundation in platform architecture and the admin center, and month 2 gave you control over DLP policies and connector governance. Month 3 builds the agent authoring proficiency you need to audit, review, and approve the agents your organization's makers are building. By the end of this 4-hour session, you will have built, published, and exported a functioning HR onboarding agent through a managed OM pipeline. Every concept covered today maps directly to AB 900 exam objectives, Microsoft 365 Copilot, and agent administration fundamentals. If you have not yet scheduled your Pearson VUE sitting, this month is the time to do it. The session runs across 4 focus blocks. Hour 1 covers topic architecture, how agents decide which topic to invoke, how that decision is governed, and what happens when system topics are misconfigured. The Retail Corp case study grounds the theory in a real data governance incident. Hour 2 moves into knowledge sources, entities, and variables, the information pipeline from external data sources into conversation state, and how variable scoping shapes agent behavior as conversations move between topics. Hour 3 is build time. You will construct the HR onboarding agent for Meridian Financial Services, integrating agent flows, Power Automate, and the request for information approval pattern. Hour 4 brings everything together with solution export and import using the PAC CLI, team demonstrations, AB 900 exam prep, and a briefing on your offline deliverables. One important note on the AB 900 certification gate at the bottom of this agenda: the exam is not optional coursework for this track. Month 4 content covers generative orchestration, autonomous agents, and multi-agent coordination, all of which build on the AB 900 knowledge baseline. Schedule your exam before month 4 begins. 5 objectives build on each other across this session. The first is to author custom and system topics using both classic trigger phrase mode and generative description-based mode, and to articulate the governance implications of each system topic. Understanding authoring mechanics is not academic. As an administrator, you need to be able to read an agent's topic tree and identify misconfigurations before they reach production. The second objective is to configure knowledge sources, SharePoint, public websites, file upload, and graph connectors, with endpoint filtering controls aligned to your DLP policy. The carryover from month 2 is direct. A DLP policy that blocks SharePoint will silently prevent SharePoint knowledge sources from returning results. The third objective is to design entity extraction using pre-built and custom entities with slot filling, and to manage topic, global, and system variables, including the full set of user system variables. Variable scope decisions made at authoring time determine whether authentication state survives topic transitions. The fourth objective is to build agent flows using natural language and the flow designer. Integrate Power Automate cloud flows as callable tools with typed inputs and outputs, and implement the request for information human review pattern. The fifth objective is to deploy an agent through a solution-aware OM pipeline, packaging, export, import, and publish, and to understand exactly when and why authentication changes force a mandatory republish. When a user sends a message to an agent, the agent must decide which topic to invoke. There are 2 fundamentally different models for that decision. Classic trigger phrase mode uses a classification model. Each topic in your agent is configured with up to 200 trigger phrases, exact or fuzzy match strings. At runtime, the classification model selects the best matching topic. The routing is deterministic in the sense that it depends directly on the quality and coverage of your phrase list. If you write comprehensive, well-differentiated phrases, you get predictable routing. This predictability is a governance asset. You can audit the phrase list, identify gaps, and reason about which inputs will and will not trigger each topic. Generative description-based mode works differently. Instead of phrases, you write a natural language description of what the topic is for. At runtime, the generative orchestrator reads all topic descriptions and decides dynamically which topic applies to the incoming message. Authoring is faster. Routing is less predictable, especially when two topics have overlapping purposes or ambiguous descriptions. In regulated environments handling sensitive customer data, classic trigger phrases are typically preferred for deterministic routing on sensitive workflows. Generative mode is better suited to informational or broadly scoped topics where routing flexibility matters more than predictability. The building blocks of every topic are three core node types. The question node prompts the user for input and stores the response in a variable. It keeps reprompting until the user provides input that satisfies the linked entity type. If no entity is linked, it accepts any string. The message node delivers a response without waiting for input and supports rich content including adaptive cards, images, and quick reply buttons. Condition branching implements if and else logic driven by variable values. The most security-critical condition branch in any authenticated agent is the one that checks the system variable user, is logged in before allowing access to sensitive content. System topics are the platform-level scaffolding that every agent includes automatically. Unlike custom topics, you did not author them. They were created by the platform. Some are editable, some have limited editability, and every one of them carries governance implications when misconfigured. Conversations start fires when a session begins. It is editable and often customized to deliver a welcome message. The governance risk is information leakage before authentication completes. If the conversation start topic reveals internal architecture, data connections, or system context to an unauthenticated session, you have disclosed more than intended before the agent has confirmed who it is speaking with. Fallback is the highest-risk system topic in any agent with generative capabilities. When no custom topic matches the user's input, fallback fires. If generative answers are enabled on fallback, the agent will attempt to answer from its knowledge sources, including SharePoint knowledge sources, regardless of whether the user is authenticated. This is the configuration path that leads to unfiltered sensitive content being returned to anonymous users. Escalate routes to a live agent or human support queue. The governance risk is SLA bypassing. If the escalate topic routes to the wrong queue or channel, your human agent handoff service level agreements break silently. Require users to sign in is a toggle, not a complex topic, but it is binary in its effect. When disabled user is logged in is always false for the entire session. There is no gradual or partial effect. With this toggle off, authentication never happens, and any condition branch checking user is logged in will always take the unauthenticated path regardless of who the user actually is. Reset conversation clears all global variables including user. Access token. If any topic in the agent invokes reset conversation mid-session, even with good intentions, such as providing a restart option, any downstream power automate flow call that depends on the OAuth token will fail silently. The flow call will succeed at the HTTP level, but the downstream API will receive an empty or invalid token. Multiple topics matched controls the disambiguation experience. In classic mode, it defines the prompt shown when two topics score closely. In generative mode, the orchestrator resolves ambiguity internally, and this system topic has limited effect. The governing admin rule across all of these. Never customize fallback or escalate without first testing the full unauthenticated conversation path. That is the path available to anyone who reaches the agent without authenticating, and it is the path most likely to expose a misconfiguration. Retail Corp deployed a product agent with 2 configuration failures that combined to produce a serious data governance incident. Unauthenticated users were receiving unfiltered product pricing data from internal SharePoint knowledge sources. 3 issues contributed. First, The fallback topic had generative answers enabled. This meant any unmatched query triggered a knowledge source call and returned a generated answer with no authentication check before the response was delivered. Second, the require users to sign in toggle was deactivated. User is logged in was always false, meaning the platform never challenged any user to authenticate before starting a conversation. Third, the individual topic conversation paths did not include a condition branch checking user is logged in at entry. Even if a topic was designed to protect sensitive content, there was no gate in the topic itself. The corrective steps address each issue in sequence. For the fallback topic, disable generative answers. Route unmatched queries to a static safe message. I could not find an answer to that. Please contact HR or directly to the escalate topic. Generative answers on fallback are appropriate only in agents with no sensitive knowledge sources and fully authenticated sessions. For authentication, enable the require users to sign in toggle and test immediately in the test pane without signing in. The agent must challenge for credentials before allowing any conversation to proceed. For topic-level gates, add an if/else branch at the entry point of every topic that accesses knowledge sources. If user is logged in is false, redirect to a sign-in prompt and exit the topic. This belt and suspenders approach ensures that even if the system topic is reconfigured in the future, the individual topic provides a second authentication gate. These three fixes together represent the minimum remediation required before the agent can re-enter production. Applying only one or two of them leaves a gap. Knowledge sources are how agents retrieve information beyond what is directly encoded in their topics. There are 4 source types in Copilot Studio, each with distinct authentication models, filtering capabilities, and refresh behaviors. Public website sources are crawled without authentication. The agent accesses publicly available URLs. Endpoint filtering via URL allowList and blocklist is available and should always be configured. Without a restrictive allowList, the crawler may index pages you did not intend to include. Content refresh is manual or scheduled. Use case: product documentation, public FAQs, marketing content. SharePoint and OneDrive sources authenticate using either delegated credentials, where the agent queries SharePoint with the signed-in user's permissions, or app-based credentials via a service account. The distinction matters for data governance. Delegated authentication means SharePoint security trimmings apply. Users only see content they have access to directly. App-based authentication means the service account's permissions determine what is returned, regardless of which user initiated the query. Per-site path filtering is available. Content refresh is automatic via Microsoft search indexing. File upload sources require no authentication and offer no endpoint filtering. The file is embedded in the agent's knowledge base at upload time, and re-upload is required to update the content. Use case: static reference documents such as policy PDFs or product catalogs. The governance risk is stale content. There is no automatic refresh signal when the source document is updated at its origin. Graph connector sources authenticate via Entra ID and require a graph connector to be configured and approved at the admin level before it is available for agent use. Endpoint filtering is governed by DLP policy. Content is managed by the connector itself. Use case: enterprise search across systems that surface content via Microsoft Graph. The relationship between DLP policy blocking and endpoint filtering is critical to understand. DLP blocking is an admin plane control that prevents connector use entirely across an environment. It is set in the Power Platform Admin Center and affects every agent in the environment simultaneously. Endpoint filtering is an agent-level control that refines which URLs or site paths are queried within a connector that DLP already permits. Both controls can coexist. DLP defines the outer boundary. Endpoint filtering narrows within it. Endpoint filtering cannot override a DLP block. The most common knowledge source problem following month 2 is a DLP policy that blocks the SharePoint connector, causing SharePoint knowledge sources to fail silently. There is no error message in the agent. The knowledge source simply returns no results. The agent continues operating as though nothing is wrong, but it is drawing on no information. When you block the SharePoint connector in your Month 2 DLP policy by placing it in the blocked group, you applied an environment-wide control. Every agent in that environment loses the ability to use SharePoint as a knowledge source. This is the correct governance outcome for environments where SharePoint access should not be permitted. It is the wrong outcome for environments where SharePoint access is intended and required. The two-layer control model gives you flexibility. At the DLP layer, you permit the SharePoint connector in environments where agents legitimately need internal document access, typically your production and UAT environments. In development environments where agent authoring is exploratory, SharePoint may remain blocked. At the endpoint filtering layer, within environments where SharePoint is DLP permitted, you configure each agent's knowledge source to query only specific site paths. The HR SharePoint site, the IT knowledge base, the policy library. This prevents an agent from querying across all SharePoint content the service account can access. If your Month 2 DLP configuration blocked SharePoint broadly, and you need SharePoint knowledge sources for today's challenge, you have two practical options. Adjust the DLP policy to move SharePoint from blocked to business for the environment you are working in, or build the knowledge source in a different environment where SharePoint is already permitted. Document whatever change you make, and the rationale, DLP policy changes, affect every agent in the environment and should be treated as change-managed events. Entities are the extraction model that turns free text user input into typed, structured values. Without entities, every piece of user input is a raw string. With entities, the agent automatically parses user input into dates, numbers, email addresses, employee ID, or department names before that value is stored in a variable or passed to a flow. Microsoft provides 9 pre-built entity types that require no configuration: person, email, number, date and time, age, currency, phone number, URL, and Boolean. These are immediately available in question nodes. Microsoft maintains the extraction models for each type, including handling of natural language variations, relative dates like next Tuesday, written numbers like 500, and email addresses embedded in sentences. Custom entities fall into 2 categories. Closed list entities define a fixed vocabulary with synonyms mapped to canonical values. This is the right choice when the set of valid values is known and bounded: department names, product categories, location codes, service tier names. The canonical value is what gets stored in the variable. Synonyms are every way a user might express that value. The mapping from HR, human resources, people team, and people operations to the single canonical value, HR, ensures that downstream flow calls receive clean, normalized values regardless of how the user phrased their input. Inconsistent values passed to Dataverse or an HTTP API produce failures that are difficult to diagnose. Rejects entities match user input against a regular expression pattern. This is the right choice for structured codes that cannot be enumerated. Employee ID following a fixed format, case numbers, invoice references, booking codes. The example on this slide shows a question node configured with a rejects entity for employee ID using the pattern EMP_D6. When the user types, "My ID is EMP042781," the entity extractor returns EMP042781 as the variable value without capturing the surrounding sentence. The enterprise agent design principle is to always prefer a typed entity over a raw string capture for any value that will be passed to a downstream flow or used in a condition branch. Raw string captures introduce variability that breaks integrations silently. Slot filling is the mechanism that reduces conversational turns by extracting entity values from prior utterances before the agent asks for them explicitly. When a user's opening message contains information the agent is going to need, slot filling captures it automatically rather than asking a separate question. The mechanism is enabled by setting the identify property on a question node to the target entity type. When this property is set, the agent attempts to extract the entity value from all prior user messages in the current topic before prompting for it. If the value is already present in the conversation history, the question is skipped. If it is not present, the agent asks normally. Consider this conversation. A user opens with, "I need to book leave for Sarah Jones in HR next week." The agent has question nodes for department, employee name, and date range. With slot filling enabled and entity types correctly set, the agent extracts HR for department and Sarah Jones for employee name from the opening message. The only question it needs to ask is the one for which no value was provided, the specific dates. The user answers 15th and 16th of June. The agent confirms and submits. A conversation that might have required 5 separate questions is resolved in 2 turns. The efficiency gain compounds in high-volume enterprise agents. Users who provide context upfront, which experienced users naturally do, experience significantly shorter conversations. Users who do not are prompted in the normal sequence. The most common pitfall with slot filling is configuring a question node with an entity type visible in the node settings, but forgetting to enable the identify property. When identify is not set, the entity type is defined but slot filling does not occur. The agent will always ask the question regardless of what the user has already said. The diagnostic test is straightforward. Open the test pane, type a sentence containing entity values for multiple question nodes, and verify that the agent skips the questions for values already provided. If it asks every question in sequence, the identify property needs to be checked on each node. Variable scope is one of the most consequential design decisions in any Copilot Studio agent. The wrong scope choice produces runtime failures that are difficult to diagnose, data that disappears mid-conversation, authentication state lost between topics, flow calls that fail because the token they needed was cleared. Topic variables exist only for the duration of the current topic. When the topic exits, whether by completing normally, by a go-to-topic action, or because the user triggered a different topic, topic variables are cleared. Use topic variables for intermediate values within a single conversation branch. The user's selection from a presented list, a calculated value used and discarded within one flow of the conversation. Global variables persist for the entire conversation session and are accessible from every topic. Use global variables for user profile data and state that must survive topic transitions. The user's department, their employee ID, their manager's name, a reference number generated at the start of the session. Any value that a downstream topic will need should be global. System variables are set by the platform and are read-only. They persist for the entire conversation session. The 4 most important are user ID, which is the unique identifier from the identity provider and is suitable for dataverse lookups. User display name, which is the user's display name from the identity provider and is the right input for personalized greeting messages. User access token, which is the OAuth bearer token for delegated API calls and must never be logged, exposed in message nodes, or stored in Dataverse. And user is logged in, which is a Boolean that is true only when the require users to sign in system topic is active and authentication has successfully completed. User is logged in is the condition gate for every security-sensitive branch in the agent. If this variable is false when the agent reaches content that should be restricted to authenticated users, the agent must redirect to a sign-in prompt and stop. A false value here does not mean the user failed to authenticate. It may mean the require users to sign in toggle is off and no authentication was ever attempted. Both scenarios require the same response: block access to protected content. When a topic's work is done and it hands off to another topic via a go-to-topic action, topic variables do not transfer automatically. They are scoped to the topic that created them and are cleared when that topic exits. Passing values between topics requires explicit variable passing through a declared input and output interface. The pattern has 4 steps. In the calling topic, add a go-to-topic action node, select the target topic, and map calling topic variables to the called topic's declared input variables. This mapping is explicit and type-checked at authoring time. In the called topic, declare input variables in the topic's trigger configuration with the expected types. These receive the values passed from the caller at runtime. To return values, the called topic declares output variables. When the called topic completes and returns control to the caller, the output values are available to be mapped back to the caller's own topic or global variables. For values that need to be accessible across all subsequent topics without explicit passing each time, use a setVariableValue action to write the value to a global variable. This is the more convenient approach for widely shared state, like the user's department or their authenticated user ID. To make this concrete, a calling topic passes department and employee name as input variables to a topic called Submit Leave Request. That called topic processes the request and returns a confirmation ID as an output variable. The calling topic reads topic confirmation ID after the topic call completes and uses it in a confirmation message. One critical warning applies to global variables and the reset conversation system topic. Reset conversation clears all global variables, including user, access token. If any topic in the agent invokes reset conversation, even with good intentions, any Power Automate flow call after that point that requires a delegated OAuth token will fail silently. The flow call will receive an empty or invalid token and either error internally or make an unauthenticated API call with unpredictable results. Before using reset conversation in any agent that integrates with authenticated APIs, trace through every downstream flow call that runs after the reset point. Agent flows are Power Automate flows built within the Copilot Studio authoring experience and callable from topics as tool actions with typed inputs and outputs. The authoring pipeline moves through 4 stages. You begin by describing the flow's purpose in plain English. For example, when called with an employee ID and leave start and end dates, create a leave request record in Dataverse and return the confirmation number. Copilot Studio takes this description and generates a starter flow in the embedded flow designer. The generated flow is a starting point. It establishes the basic structure, but will typically need editing to add the correct connector actions and configure error handling. The full Power Automate canvas is available within Copilot Studio. Every connector category is accessible here. HTTP requests, Dataverse create and read operations, SharePoint file handling, Teams messages, and the approvals connector for human review workflows. You build the complete flow logic using the same designer surface available in standalone Power Automate. Once the flow is complete, you add it to the agent as a tool. The flow appears as a callable action in topic authoring. When a topic node calls the flow's input parameters are passed as typed variables, and the flow's output parameters are returned as typed variables that the topic can read in subsequent nodes. The critical governance rule for all flow tools, whether built as agent flows or added from the main Power Automate portal, is that every input and output parameter must have an explicitly declared type. A flow that returns an untyped or generic JSON object forces the topic to parse a raw string. This is fragile. It breaks silently whenever the JSON structure changes, and condition branches that evaluate the output will behave unpredictably. Always define output parameters with their types: string, number, Boolean, or date. When reviewing a maker-built agent for production readiness, checking every flow tool call for untyped output parameters is one of the most valuable audit steps you can perform. The request for information pattern is the most important enterprise integration pattern in Copilot Studio. It implements a human-in-the-loop approval loop within a conversational agent. The agent collects structured data, submits it for human review, waits for a decision, and branches based on the outcome. The pattern flows through 5 stages. In the first stage, the agent collects structured data from the user via question nodes with entity-typed variables, employee name, department, leave dates, leave type, whatever the workflow requires. In the second stage, the topic calls a Power Automate flow that creates an approval request via the Approvals connector. The flow sends an approval card to the designated approver, typically via Teams or the Approvals portal. In the third stage, the conversation enters a waiting state. From the user's perspective, their request has been submitted and is pending approval. The topic is not progressing. It is paused, waiting for the flow's output variables to be populated by the approver's action. In the fourth stage, when the approver acts on the approval request, the Power Automate flow completes and returns typed output to the topic. The critical output parameter is approval status as a string variable with values of approved or rejected. An optional approver comments string variable carries any reviewer notes. In the fifth stage, the topic reads the approval status variable in a condition branch. If the value is approved, the agent sends a confirmation message and proceeds with downstream actions, notifying the requester, updating a system of record, or completing the workflow. If the value is rejected, the agent sends a rejection message including the approver's comments. The typed output requirement is not optional. The flow must declare approval status as a string output parameter with defined values. If the flow returns an untyped or improperly typed output, the condition branch will not evaluate correctly. It will always take the else path, and approvals will be silently rejected regardless of the approver's actual decision. Before integrating any approval flow, verify the output parameters in the flow designer. The DLP alignment requirement also applies here. If the approvals connector is in the blocked group in your environment's DLP policy, the RFI pattern cannot function. Verify DLP alignment before building this pattern in any environment. Publishing is a frequently misunderstood step in the agent deployment process, and the misunderstandings produce predictable production incidents. The first rule is that an agent must be published at least once before any channel tile becomes interactive. This is not a caching delay or a propagation latency. It is by design. Channel tiles in Teams, web chat, and custom integrations are activated against a published version of the agent. An agent that has never been published has no published version for channels to activate against. Saving the agent does not publish it. The explicit publish action must be taken first. The second rule is that changing the authentication configuration requires a republish, and after republishing, all previously activated channels must be reactivated. This is the most common source of post-deployment breakage. When you switch from no authentication to Microsoft authentication, or change any aspect of the authentication configuration, the current published version is invalidated. Users on existing channel integrations will encounter errors or experience the agent behaving as though the previous authentication model is still in effect, because from the channel's perspective, it is. The mandatory sequence is change authentication, republish, reactivate all channels. The third rule is to test before publishing. The built-in test pane simulates the full conversation flow within the authoring environment. Before any publish, verify that all topic paths are reachable, variable captures work as expected, flow calls return the correct output, and the user is logged in gate behaves correctly for both authenticated and unauthenticated scenarios. Publishing packages the current agent state as the live version. If that state has an untested path, the untested path is now in production. The complete publication sequence is build the agent, configure authentication, test in the test pane with particular attention to the authenticated and unauthenticated paths, publish, activate channels, and republish with channel reactivation whenever authentication settings change. Each step depends on the previous one completing correctly. Application lifecycle management is how production agent deployments are governed and made repeatable. The foundational constraint is this: an agent built outside a solution cannot be promoted to another environment via a pipeline. This constraint is by design, and it is not a deployment time workaround. Solutions must be created before authoring begins. The environment flow for a governed deployment is: a development environment holds an unmanaged solution where the agent is built and iterated. When the agent is ready for production, the solution is exported as a managed package, a zip file. That package is imported into the production environment, where it arrives as a managed solution that is locked against direct edits. Changes to the agent in production must arrive via the pipeline, not through the production authoring surface. There are 3 decisions that define a sound OM practice. First, always create the solution before starting agent authoring. An agent created in Copilot Studio and then added to a solution later may not transfer cleanly. Some component types do not move reliably. Solution first is a mandatory team practice, not a guideline. Second, choose the right solution type for each environment. Export managed solutions to production. They prevent direct editing in the target environment, ensuring that production state is always a known, pipeline-deployed version. Export unmanaged solutions for development and UAT environments where iteration is expected. Third, for enterprise-scale deployments, Power Platform pipelines in the admin center automate the export-import cycle with approval gates and environment routing rules. Manual PAC CLI execution is appropriate for learning and for smaller deployments. The PAC CLI sequence for a manual deployment is: authenticate the CLI to the tenant with PAC auth create. Export the solution from the source environment with PAC solution export specifying the solution name and the managed flag. Import the package to the target environment with PAC solution import, and then trigger publish with PAC Copilot publish using the agent's ID. That last step, the explicit publish after import, is mandatory. Importing a solution does not automatically publish the agent in the target environment. The agent must be published before any channels in the target environment become active. The Hour 3 challenge builds the agent that Meridian Financial Services HR team needs, an HR onboarding agent that guides new employees through onboarding steps, retrieves HR policy documents, and submits onboarding forms via Power Automate, all behind an authentication gate. The challenge has 5 tasks. Task A requires authoring at least 3 custom topics using question nodes with slot-filled entities. Every topic that accesses sensitive content must include a condition branch gating on user, is logged in. If the value is false, the agent must redirect to a sign-in prompt and not proceed. Task B requires adding a SharePoint knowledge source with endpoint filtering limited to the HR SharePoint site path. Before adding the knowledge source, verify that your DLP policy for this environment permits the SharePoint connector. If it does not, the knowledge source will fail silently, and you will need to adjust the policy or use a different environment. Task C requires creating an agent flow using the natural language authoring feature, promoting it to the full flow designer, adding at least one connector action, HTTP or Teams message, and wiring it as a typed tool in a topic with declared input and output parameters. Task D requires calling a Power Automate cloud flow that sends a Teams notification on form submission. After the flow call, demonstrate reading typed output from the flow in a topic condition branch. The condition branch must evaluate the output variable correctly to prove that the output parameters are properly typed. Task E requires adding the agent to a solution before any other authoring begins. This is step 0. Once the agent is complete, publish it. Activate at least one channel and export the solution as a managed zip package using the PAC CLI sequence covered in the previous slide. The checkpoint gate for Hour 4 demos requires that the agent is publishable with no authoring errors, that channel tiles were inactive before the first publish and active after it, and that the PAC solution export command produces a valid managed zip file. The demo covers the topic tree, a live knowledge source query in the test pane, slot filling demonstrated with a multi-entity opening message, a Power Automate flow trigger, and the solution export. The AB 900 exam is 45 minutes, beginner level, delivered via Pearson VUE either in person or online proctored. It covers exactly the content of this session and the foundations from months 1 and 2. Schedule your sitting before month 4 begins. The exam tests across 5 domains. Topic management covers trigger phrases versus description-based mode, system topic governance, and the behavior of fallback, escalate, and require users to sign in. Exam questions in this domain are scenario-based. Given a symptom, users receiving content without signing in, an agent returning unexpected results, which configuration change is required. Knowledge sources covers source types, the distinction between endpoint filtering and DLP blocking, SharePoint delegated versus app-based authentication, and knowledge refresh mechanics. The most common exam trap is conflating DLP blocking, an environment-level admin-managed control with endpoint filtering, an agent-level maker-managed control. Entities and variables covers pre-built entity types, know all 9 the selection criteria for closed list versus rejects entities, slot filling mechanics, the 3 variable scope types and when each is appropriate and the user is logged in gate. Know that user. Access token is read-only, must never be exposed in message nodes, and is cleared by reset conversation. Agent flows and integrations covers natural language flow authoring, the mechanics of adding a Power Automate Cloud Flow as a type tool, the requirement for explicit input and output parameter types, and the request for information approval loop from data collection through to approval branch. And publication covers solution-based packaging, the difference between managed and unmanaged solutions, and when each is appropriate, the export and import sequence, the publish cycle, and the mandatory republish after authentication changes, and Power Platform deployment pipelines. To prepare, complete the Microsoft Learn path, create and publish agents with Microsoft Copilot Studio, approximately 4 hours across 6 modules, and the canonical exam preparation resource. Review the AB 900 official study guide on Microsoft Learn. Register at the certification page at learn.microsoft.com. Month 3 closes with 4 offline deliverables, each carrying 25% of the assessment weight. All are due before month 4 begins. The topic architecture document covers the entity plan, variable scope map, and system topic governance decisions for the HR onboarding agent you built today. It should answer which entities are used for which question nodes, why each variable is global or topic scoped, and what configuration was chosen for the fallback, and require users to sign in system topics with the rationale for each choice. The working prototype is the live agent demonstrated during the Hour 4 session. It must show a functioning topic tree, an authenticated conversation, a knowledge source query returning results, slot-filled entity capture, and a Power Automate Flow invocation. The live demo is the submission event for this deliverable. The agent flow report documents the flow design, the RFI pattern implementation, and typed input and output parameter definitions for all cloud flow integrations built during the challenge. Include the flow trigger definition, the connector actions used, and the output parameters declared. This is the documentation that any engineer inheriting the agent will need to maintain or extend the integration. The validation report provides a step-by-step walkthrough of the solution export and import process, the publish cycle decisions documented with their rationale, and an AB 900 readiness self-assessment that identifies which exam domains you feel confident in and which require additional study before you sit the exam. Month 4 builds on everything covered today. The topic is generative orchestration, autonomous agents, and multi-agent coordination, the frontier of what Copilot Studio can do in enterprise environments. Participants who complete the AB 900 and submit strong Month 3 deliverables will enter Month 4 with the technical fluency it requires.